Notice that I did not say today we're going to begin our discussion of chemistry, even though it's the first day we've officially opened up the textbook, because we've been talking about chemistry already, right? We've been talking about tools that you're going to use to study chemistry more effectively. Learning to measure volume in a graduated cylinder, learning to light a Bunsen burner. Well, today we're going to talk about yet another tool that you can use to learn chemistry more effectively. Here's one. What about the scientific method? It's a tool that chemists use to do their work, but actually not just chemists. You will use the scientific method every day of your life. You really could. And man, if you do, you're going to be the kind of thinker that any employer is going to want to hire. Hey, what if you're driving on the road, okay, minding your business, listening to your tunes, right? All of a sudden, you hear this thump, 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 and your steering wheel starts to shake and you start to veer off the road. Do you go, oh, that's kind of an interesting little rhythm. I wonder if it's going to go with my music. No, you don't do that, do you? Okay, after your heart gets out of your stomach, what do? You pull over. Because didn't you have this thought in your head? You thought, oh no, I ran over a bunny and it's dragging into my car. I mean, probably either that or a flat tire. Man, right. So see, you know what you just did? You used the scientific, and you probably didn't just pull over and just sit there. You either got out, got the tire out, got the jack out, right? Or you picked up your phone, Dad, one of those. And they came and changed it. Hey, you know what you just did? You followed the scientific method. The scientific method is a series of steps. Now, can you not see that? Don't write yet. You see how that's a series of steps there? The scientific method is a series of steps that scientists follow to solve problems. Okay? And that's a great definition, but do you know the scientific method doesn't have to be a series of steps? I mean, are you always going to start right here, follow this arrow here, then come here and then come here? No. Sometimes you start with observations. But did you know that sometimes you'll start with a problem? I'll walk in and say, what is this something? What is this stuff? Design an experiment to determine its identity. That didn't start with observations. That started with a command, didn't it? Yeah. So the scientific method is steps that scientists follow, but not always in the same order. The scientist is going to choose what set of steps, which order is going to be of benefit to him or her. And that's what I want you to do. But just to keep it straight in our head, we're probably going to talk about it as a list, but I want you to know that the scientific method probably really looks more like this. You ready? How do you like that scientific method? You see all the parts are there, but it's more like a road map, isn't it? And I want you to think of that as a scientific method. You don't always want to stay in one loop. You want to kind of make your way around, but you may spend more time in the making observations, or you may spend more time in the testing, but you need to do all parts of it. And let's talk about these parts individually. One of the first things that you most often do is make observations. You'll have a question, but more than likely, you have a question after you make, ooh, what in the world is that smell? And you see the question came after the smell? Now, when I say observe, I mean describe your system. You're going to use your senses. What does it look like, smell like, taste like, feel like? Is it hot? Is it cold? Is it rough? Is it smooth? And when I say use your senses to make observations, they will be qualitative or quantitative. Now, in these two words, do you see other words? Okay, what about qualitative? What word do you see inside the word qualitative? Do you kind of see quality? Do y'all see that? Okay, quality does just that. It tells you the quality of something. I could say Lauren has brown hair. Michael has on a white shirt. Okay, Michael is tall. This room is cold. Those are all qualitative observations because I'm using my senses to describe the quality of something. But sometimes you need more information. Like I may say, Michael is tall. But could I be more specific than that? How could I be more specific? Michael is 6 feet tall. All of a sudden now, I'm giving you way more information, right? And with the number. Hey, do you recognize the word inside this word quantitative? What is the word? Quantity, that's right. Quantitative observations tell you how much. Well, they have a number in them. Quantitative observations have a number, often telling you how much. I can say this room is cold, that's qualitative. How could I make it quantitative? Yeah, this room is, yeah, 60, 70 degrees. You see? This room is 19 degrees Celsius. That would be a cold room, or cool room, anyway. Okay? Qualitative and quantitative. Now, I want you to be careful. Don't get so jaded that you can't see what's going on around you. Do you know what I'm talking about? Have you ever been in a situation so many times that you don't even realize it anymore? Like, you don't even smell your own perfume anymore, you know? Or you don't even hear that music anymore. Okay, always be alert to observations that are new or ones that have been around you all that time. Okay, so be attuned to that fact. Often scientific discoveries have come, though, from unexpected observations. Don't be afraid to make observations of things you didn't plan on happening. There was a man, his last name was Fry, F-R-Y, and he worked for 3M, and he was making adhesives. You know what an adhesive is, like a glue? You know how you make tape? You get this plastic, and you put sticky stuff on the outside of it, and you make it real thin, and that's tape. And so that's what he was trying to come up with, more effective tapes. And the latest glue he made was not a very good glue. It did not stick well at all. And he told his friends about it. This glue, as soon as you put it on, it comes right off. You know, it is not a very good glue at all. Well, his friend happened to be at choir practice, of all things. And his bookmarks for his music, he was putting bookmarks in different, they kept falling out. Because you know how you have to put music on a stand? He said, oh my goodness, I wish I had something I could tape these in, but I can't because I don't want to ruin the music. He said, wait a second. He called his friend and he said, hey, that glue that you made, he said, put some of it on the back of paper for me and cut it into strips and let me have it. And he took it and he put his bookmark into place on the sheet music, and then when he was done with it, he took it right off. And guess what was born? Sticky notes. Isn't that wild? That's an example of unexpected observations leading to something that actually was of great benefit. Hey, and communication was important there too, wasn't it? We'll get there in just a second. Now, be really, really careful about this next thing about observations. I ask for your observations. I'm not asking for your opinion. Do not infer. Do not form conclusions. I'm asking for observations. Are you real good at giving your opinion? Oh, yeah, me too. No, I want your observations. Not, he is ugly. No, why do you think he's ugly? Well, that was really kind of mean, but you get my picture. Okay? He has 3 eyes. He has no teeth. That kind of thing. Okay? Now, look at this picture. Let me turn the lights off. I want you to begin making observations of this picture. Okay? So shout out your observations. Say them out loud. Just brainstorm. Okay, pink, sky, green. What else? Cloudy. Somebody else. Tree. Did I hear somebody say tree? Yes. Okay, tree. What else? Grass. What? Hill. What? Open. Yeah, okay. Say it again. Oh, blue. Okay, somebody else. Nature. What did you say, Lauren? Deserted. Okay, now look at this picture. You ready? This is actually the right picture. That picture's upside down. This is the right picture. Now, make observations. It's not the sky, it was a pond. And it's not a tree, it was a bush, the ground, grass. Yeah. Isn't that wild? Isn't that wild? And that's really not the sky. Did I just say sky? Sky, what did you say it was? It's a reflection of the sky. Isn't that the coolest thing? You see what I'm saying? Hey, you got to be careful of making inferences and conclusions and opinions. Make observations. Don't just tell me it is. Tell me why you think it is. You know, what do you see that makes you have that opinion? Okay? One of my favorite stories is a story that Dr. Rogers tells. Do you know who Dr. Adrian Rogers is? He's a preacher who's now in heaven with the Lord, but I listen to him every morning when I'm getting ready. But he tells a story that I love because it's a really good lesson to me. I think this lady he knew. He knew this lady, and she was flying somewhere. You ever flown? So you know you've got to get there like super early. So she got there, and she checked in and everything, and so she went to those little kiosks and bought some cookies. And so she gets back to the gate. She's just sitting there. There's this man beside her, and she's got her cookies right here beside her. So here's her. Here's cookies. There's the man. That's important for the story. And so she opens the cookies and she takes one. She eats it, and the man smiles at her. She smiles at him. And the next thing you know, complete shock, the man reaches over and gets a cookie out of the bag and eats it. Okay, she's freaking out and thinking, okay, maybe a smile in his language means, please take a cookie, I mean, it's just freaking her out. And so, she's like, okay. So she reaches over and she gets another cookie. He does too. She reaches over and gets another cookie. He reaches in her bag and gets another cookie himself. So now she is like beyond mildly concerned. She is flat out mad. Just fit to be tied. This man is stealing her cookies, right? And so she is just furious. And so it finally gets in. So they got like a war of cookies. And so I can just imagine Famous Amos, So do you like Famous Amos chocolate chip? Oh, I do too. Anyway, so she looks in the bag. There's one cookie left. You will not believe what he did. He reaches over and in the bag, picks up the cookie out of the bag, breaks it in half, and smiles and hands her half. Well, she is just livid. About that time, they call for her. She has to board. And so she gets in the plane just fuming, just furious. Well, they take off. The seatbelt light goes off. Y'all know what I'm talking about. That's when you can get up and get your stuff. So she gets up and she gets her purse and pulls it down and opens it up. And guess what the first thing she sees inside her bag? Her bag of cookies. She had been eating his cookies the whole time. You got to be careful about making conclusions without all the facts, right? And that's what I want to tell you here. The Bible says, you remember that verse? We say it all the time, judge not, lest you be judged. You know that verse I'm talking about? I don't think the Bible's talking about us to not. I think God wants us to be discerning and discriminating. Oh, my goodness. You got to eat a sandwich out of the refrigerator. You better be judging whether it's good or not, It's 2 o'clock in the morning, somebody knocks on your door. You better use some good judgment about whether or not you open that door, especially if he's wielding an axe. You know what I'm saying? But I think we've got to make sure that we judge with discernment, with mercy, right? Get all the facts before we start judging. I think that reminds me of that every time I hear that story. Okay? So now then, you've learned you're only making observations. So what do you do with them? Here's a beautiful set of observations. What are these observations? They're letters. Hey, could you memorize it? O-T-T-F-F-S-S-E. I bet you could memorize. You could probably make 100 on the test tomorrow, couldn't you? White background, black letters. I bet you could even repeat this, couldn't you? What meaning does it have? Nada. In other words, you could memorize your entire chemistry textbook and it would be good for nothing. When will it become useful? When you can apply it. When you can make use of it. So I don't want you to be a hoarder. You're hoarding all these facts in your head. I want you to make use of them. So, why are the letters like they are? What is the order? If I were to ask you, does something come after E or does something not come after E? Could you tell me? Well, you're to this step then. When you begin to try to find patterns in your observations, you come up with try to find a reason for your observations, then you're formulating a hypothesis. A hypothesis is an explanation based on your observations. You're looking for patterns in your data that can suggest an explanation for your observations. Hey guys, are y'all learning how to take notes in here? Have you figured out I go pretty fast? Are you writing down the keywords? And don't forget, if you need to, you can always go back and watch the podcast again. Hypothesis. You're looking for an explanation for your observations. Okay, let's go back to these letters. Okay, now wait a minute. I'm observing that most of you are writing word for word what I'm saying. You're not going to have time to finish if you do that. Just write the main ideas. Okay, go back. You may know this because you may have heard, even though I told them not to tell you. And so if you know this because somebody told you, don't say it out loud. But what is the next letter? O-T-T-F-F-S-S-E blank. Does anybody know? Okay, tell me. There's not one. That's a great guess. I put that there. Trick, have you ever seen these? That's a great hypothesis. Wait a second. That's not right. Can that be? Can you have a hypothesis that's not true? Sure. Okay, somebody give me another guess. An E. Oh, my goodness. Obvious answer, right? Because you got all the letters repeating. T-T-F-F-S-S-E-E. Obvious. Hey, it's based on observations. And she even tested it by asking me to see if it's right. Guess what? It's not. Guess again. Yeah. Oh, great reasoning, I think. You tell me, and let's see. Why did you pick? It began with an O. It could end with an O. That's a great lot. Well thought out based on your observations, right? Did y'all hear that? Based on its observations? Okay, yeah, that's not it, though. I want you to puzzle it out. I want you to see if you can find what the next letter is. Now, think of it as we go through the period. Do you think you have it already? D. Why did you say D? So you've got kind of like a pattern going, right? The vowels are repeating, but you're letting, like, the F comes before E, T comes before S, S comes before R. Is that what you're saying? It's a great, based on your observations, but it's not right. Anybody else want to try it? Hey, is it okay to be wrong? Well, not on a test, it's not that great, but it's okay to be wrong because if you don't ever guess, you would never know that R is not right. Do you see? So that's a great thing to guess. Well, think about it. Hopefully we'll get to it toward the end of the period, okay? Let's keep going. With a hypothesis, did you learn this definition in elementary school? I didn't. What did you learn? 2 words. What did you learn? What definition? Hey, I wonder if you learned the same thing in China that we do in the United States, Lily. What did y'all learn a 2-word definition for hypothesis? I'm not even kidding. I learned it when I was in 5th grade. So far, everybody's told me in class, they've told me the same thing. What did you learn when you were in elementary school? A blank blank. Oh, man alive. Educated guess. Did y'all learn that when you were in China? A hypothesis is an educated guess. Have you ever wondered what that means? It means this. It means a reasonable and testable explanation for observations. First of all, educated. Educated means it's reasonable. It's based on your observations. You didn't just willy-nilly go, I think it's because I ran over an elephant. No, it was based on your observations. Secondly, testable. You can actually test it. That's what makes a legitimate hypothesis. Is it based on your observations? Is it testable? Okay? Now, let me give you a couple. What about this one? Albert Einstein is the smartest man who ever lived. Is that a legitimate hypothesis? Why not? Hey, is there a way to test it? See, who lived before Albert Einstein? Could they have been smarter? Sure. Do you see? So, I've got another thing. What about intelligence? Who's to define what intelligence is? I mean, he got the Nobel Prize for his work in chemistry and physics and developed the theory of relativity, right? Oh, my goodness. But have I ever told you my favorite Albert Einstein story? Would you like me to tell you my favorite Albert Einstein? Not to chase another rabbit since we're almost out of time, but let's just go ahead. One day, Albert Einstein's secretary gets this phone call from this man. I need to know where Albert Einstein lives. She said, I'm sorry, sir. We cannot give out personal information. Well, the phone call went downhill from there. I've got to have it. No, you can't have it. I've got to have it. No, you can't have it. You get the picture? And it was like this man was insisting that she said, I cannot give out personal information. It's getting pretty heated. After about 5 minutes, she said there's this like deathly quiet on the phone, and she could hear breathing. And all of a sudden, she heard, "It's me. I forgot where I live." I'm just saying. The man can develop a theory of relativity, and he couldn't remember his own address. He could not remember how to get home. What's intelligence, right? Okay, that's chasing a rabbit. Let's go to this one. We're sitting in the middle of class. I'm lecturing my heart out. You are writing your heart out, and all of a sudden we hear Casey, "Eureka! He lives!" Because Casey has just heard "Love Me Tender" coming from the stockroom. And so Casey exclaims with great enthusiasm, "Elvis is alive! He's alive! He's not dead after all." Now, is that a legitimate hypothesis? Whoa, wait a second. Is it based on your observations? We heard "Love Me Tender," right? Is it testable? Casey, how could you test it? You can go check. Okay, do you see what I'm saying? Now, does that mean it has to be right? What if Casey goes and checks and there is no king of rock and roll in the stockroom? That means he's just got to reformulate his hypothesis, right? Okay, what about this one? There are little green men living on the moon. Okay, Brandon's with his sweetie pie, gazing at the moon at night. Okay, there's Brandon, there's a sweetie pie. He says, "There are little green men on the moon." He sees them. Okay, is that a legitimate hypothesis? Well, if he saw them, that's an observation. Could you test it? How could we test it? We could send him to the moon. Could we not send NASA to the moon or look at pictures from the moon or actually take a trip there? I'm being kind of ridiculous, but you get what I'm saying. Can your hypothesis be wrong? Yeah, but not for the reasons you may think. It can be wrong because it's not supported by your data. But don't let it be wrong because it's not testable, or don't let it be wrong because it's not based on your observations. You get the difference? Okay? In order for a hypothesis to be legitimate, it must be testable. Now, when I say test, what do I mean? How do we test in science? We do, yeah, we're going to test the validity of our hypothesis with experiments. We're going to test the validity of our hypothesis. We talked about Casey walking into the stockroom to see if Elvis was there. Okay, he was doing a test. He was testing the validity of his hypothesis. Now, what makes a good experiment? Good results. But how do you get good results? Hey, what if you don't get results? Does that mean it was a bad experiment? Did you know? I spent 3 of the best years of my life, I'm being real sarcastic there, at the University of Mississippi in the graduate research program. I could have one whole year of it was nothing because every experiment that I tried failed. I was trying to culture heart cells so that we could test different drugs on them, and they would never culture or they would die too soon. Okay, but does that mean it was a failure? No. I just found out what wouldn't work, right? So I had to find something that would work. So what are some characteristics of a good experiment? Yeah, Jake. Learning from it. Oh, buddy, yeah. What's something else? Hey, what about it's an experiment that somebody else can repeat, right? You did it. Okay, well, can somebody else? Or did you just dream it? Can you learn from it? Okay, well, how can we make sure that this is the case? There are a few characteristics of a good experiment if you're going to learn from it, if you're going to have somebody be able to repeat it. First of all, you're going to identify as many factors as possible that could make you have those observations. These are called what? These factors that could affect the results of an experiment starts with a V. Factors that can affect the result of an experiment. What do they call it? It starts with a V. Like if we wanted to know what affects plant growth, we might change water and soil and sunlight and music and fertilizer. What are all those called? It's a V word. That's it. They're called variables. Yeah. Variables are factors that you will examine. Look at that. What does it say in orange? One at a time. No, hold on. It would be much quicker to be able to test everything at one time. So why don't you? Why don't you change the soil and the water and the fertilizer and the sunlight and the music all at the same time? That's right. Then you wouldn't know which one caused the change, right? So very important. You're going to examine variables one at a time. Then you have to have a control. Isn't there going to be a row of plants you don't put anything on? Unusual? Yeah. You have to have a control. A lot of times I refer to a control as a variable that is kept constant from one experiment to the next. Why? Yeah, you wanted to see if there really was any change, right? You wanted to see, for one thing, a point of comparison. I like the way you just almost said that, Casey. A control is like a point of comparison, something you can go back and compare it to. Did it really change? Could I put any liquid on there and it would have grown just as much? Or it needed just water, that kind of thing. And then the last important thing about an experiment is you have to repeat. Repeat, repeat, repeat. In physics, I'll have a measure something 5 times. In chemistry, you don't have that luxury. You might not have, whoa, who am I kidding? Do you have time to repeat? I mean, isn't it more along the cases of, oh, please, dear Lord Jesus, let me get through this before the bell rings? So far, that's been what it's been like, right? So, you know what? You are each other's repetition. So Lauren over here gets results. She can turn and say, hey, Allison, I got a white precipitate, did you? Do you see? And so you are each other's repetition. As a matter of fact, I'm going to encourage you to share data while you're in this room. Now, not copy data, but share data. Hey, I got this. Did you get this? But be careful about that now. There's an experiment that we're going to do where I'll pick you, Grace. Grace got this ugly brown precipitate. You got a pretty blue one, you got a pretty blue one, you got a pretty blue one, you got a pretty blue. Y'all getting the picture? Okay, so what if Grace gets dark brown, but everybody in this class gets blue? Because that's going to probably happen. Does that mean the blue is right? In this case, it's not. It was the dark brown one that's right. Do you see what I'm talking about? So be careful thinking that just because everybody got it, it's right. Is the majority right always? No, not at all. Okay? Well, all these things together make a controlled experiment. Now, a lot of times I'll give you sheets, lab sheets, where you have to do a controlled experiment. Okay? And it'll be pretty much laid out for you. But there are going to be some times, oh my goodness, I just tell you what I want you to do. Here, design an experiment to identify this unknown substance. I'm not going to tell you how. You're going to have to use what we did in that chapter to figure that out. You see? And so you'll need to know the parts of a controlled experiment so you can design your own. That will happen pretty soon. Within this chapter, it'll happen. Make sure you know the parts of a controlled experiment so you can do the same thing. Well, I think we've gotten through observations, hypothesis, experiment. Now we got all this data. What do we do with it? Yeah, we need to analyze our results. Analyze our results. Do your results support your hypothesis? What if they do not? What might have to be? What? Yeah, you may have to reformulate your hypothesis. I had to a whole bunch. But when your data supports your hypothesis, then when your experimental data supports your hypothesis, then you're ready to move on to the next step. And that's form a conclusion based on your experimental results. You're going to form a conclusion based on your experimental results. It may be in words. You may have a conclusion in words. But there are a lot of theories that are not in words. Now, there's the atomic theory, and you're going to memorize, okay, pretty much. But couldn't you make me a model of an atom that would show me that you understood atomic theory? You could, couldn't you? Hey, what about that weather map up there? When I want to know the prediction of the weather for the next 4 hours, is it going to rain during soccer practice? I can go to weather.com, click on maps, and click, that feature I'm talking about, and it'll scroll through. Okay, wait a second. Those are not actual clouds, are they? That's a theory. That's a model. They modeled what their prediction was. You see what I'm saying? I don't like the word prediction. They model what their conclusion was. See? So a lot of times theories can be in models. But then guess what? Just because you have a theory, you're still not done. Through the entire process, what did you need to be doing? How about this? Now, at the end, you'll publish your results. But throughout the entire experiment, you need to be communicating your results. Don't you? If it works, if it doesn't work, don't you need to be communicating your results? So that other people can learn from you and you can learn from others. Now, scientists will do this in a journal. You know, like you'll publish in the Journal of Andrology, you know, the Journal of Endocrinology. But you're not going to be publishing in a journal. How are you going to publish your results? See those little black lab books over there? That's how you're going to publish your results. And I'll show you that later, okay? But that's what you'll do. Well, we just fairly well flew through this. Here it is, the scientific method. Are you ready to use it? Tomorrow you are going to. Tomorrow, I'm going to actually not have you start with observations. I'm going to give you a problem. You're going to have to pretty much begin with observations then next, right? After the problem. And then you're just kind of going through it, okay? Till you finally come up with a conclusion. Now, question. How many times do you have to prove your theory before it can become a scientific law? Let's start there tomorrow. Do you know the answer? How many times do you have to do an experiment and prove it right before it becomes a law? Let's start there tomorrow. Who knows what the letter is? Infinite thing? Good guess. No. Who knows what it is? Let me write it up here. Now, do you know I'm doing something on purpose to mess you up? I doubled those letters on purpose to mess you up. What? You're not. Ask me another question. That's a good guess. It's just random letters. You've seen random letters before, haven't you? Especially to mess up a password. Lori Beth says she doesn't know, but it's giving her a headache. What is it? Hey, what's the only wrong answer you can give me on something like this? To not give me one, to not try. Because remember, it almost in a way needs to be giving you a headache, doesn't it? It needs to make you think. Sometimes thinking that hard does give you a headache. I only mean that in the kindest of ways. Okay, I'll give you a hint. There's only one right answer. There's not 2 or 3 or 4 or even 5 right answers. There's only one. And tonight I want you to figure out what it is. Now, you can be sorely tempted to ask somebody in an earlier class because some of the classes finally got it because they had more time, but you're not allowed to ask them or even look it up. I want you to try to figure it out on your own. Because you have to be right tomorrow? No, you don't have to be right tomorrow. Huh? No, no. What do you think it is, Brandon? Ah. And you're right. What is that letter? Hey, are you looking for patterns? Is it the shape of the letters? Is it the order of the letter? Is it the meaning of the letters? Hey, can you tell me tomorrow? Now, listen, don't ask it. You're going to be sorely tempted, right? It's not a grade. See if you can figure it out by yourself, okay? You have a fantastic day.